It is your first day as a software engineer working for this really cool new company. You're trying to figure out why they hired you, but hey, now you're in. You had your first team meeting with some coworkers and they are really interested in you having your development environment ready so you can start working on the tickets that are waiting for you. They show you the code base and the applications that you will be working with. There are basically two components. They have a Go backend providing all the APIs for the frontend and also providing open APIs for their customers. And also they have a frontend developed using a combination of Node.js, Express, React, and Tailwind. And this is the frontend where all the features are developed and the frontend that the customers are accessing when they go through the company website. They mentioned that even though you have these readmes with all the instructions that you need to follow in order to configure both the frontend and the backend, these readmes are outdated, so they start giving you instructions on how you can install the environments for each of these applications. So as the amazing employee that you are, you start taking notes based on what they are saying. For the backend, they mentioned that you should update the operating system, install Go, configure the environment, and finally execute the application. For the frontend, they mentioned that once you have the operating system updated, you should install Node.js, configure the environment, and finally execute the application. So you start going through these notes, you start following these instructions, and you start configuring your system. You update the operating system, you install Go, install MongoDB, install Node.js. Finally, you execute the backend, and hey, it seems to be working. Now you execute the frontend, and to your surprise, the frontend communicates with the backend, and the backend communicates with the database. So everything is ready for you to start working on. Now, without even realizing, if you were using Docker, when you were creating all these instructions here, what you were doing is creating the Dockerfile. So the Dockerfile contains all the instructions for your application to be executed. Now, when you started following those instructions and you started configuring the environment, installing all the dependencies, what you were doing is building the Docker images. You were following instructions in order to configure the environment. In Docker, you follow the Dockerfile instructions so you can build a Docker image. And the moment you started executing the applications, what you were doing without even realizing is executing these Docker images, create and launch containers using those Docker images. This is what Docker comes to solve. In this video, we're going to talk everything you need to know about Docker. What it is, Docker images, containers, networks, how to use it to deliver your own applications. If you are working in IT, Docker is a must, is something that you need to understand. If you are working with Amazon Web Services, Google Cloud, Azure, Kubernetes, whatever it is that you are doing, you are going to need Docker. So in this video, we are going to cover everything you need to know. If you like the content, don't forget to subscribe. If you have any questions or any comments, please let me know in the comment section so I can get back to you as soon as possible. Let's get into it. So, what is Docker? Before digging into Docker, we are going to take this project as an example. And here you can see we have this really cool backend project. In this case, it's developed in Go. We can see all the requirements in here. We need a Unix-based system. Once we have the operating system, we need to install Go. Once we have Go, we need to clone this repository in this opt/leon devs. That is the workspace that we are going to use. Then we need to set the permissions and the owner for this specific folder. Once we have this, we need to clone this repository in this specific folder. We need to define the environment variables required by this application. In this case, we have just 3 of them. Once we have this, we need to change directory to the specific backend project, and then we need to run the Go application. So as you can see, if we copy these instructions and we go to a new terminal and we type this in here, you can see that we change directory to this specific folder. And once we are there, we are running our Go application. And take a look at what we are seeing here. Missing environment variable using development as default, and then missing HTTP server port variable. This is happening because, as you saw, we haven't defined these environment variables, right? So we are going to copy these variables here. We are going to define those variables in here. And once we have the variables, we are going to execute our application again. In this case, you can see that current environment is production and we are listening on the 8080 port. We can just curl to localhost 8080/ping. And as you can see, we have pong as a response. So we have this working endpoint, this HTTP endpoint, and we can see the requests right here. And here we have all the instructions that we need in order to execute our application. Now, as you can imagine, everyone trying to use this application will need to go through all these different steps, and we require all of them to have a Unix-based system, so they will need to get some Linux distribution or using macOS, like in this case. They will need to install Go in that operating system, and they will need to go through all this configuration that is required for our application to execute. Now, in this case, we are working with this Go example, but you can take these instructions for any programming language that you might be using. If you're working on a front end using Node.js, Express, React, or whatever technology you are using, you will have your own requirements on how users should execute your application. So you will require them to install Node and to install all the dependencies, perform an npm install, and once they have the dependencies installed, they will need to execute the application using npm run. If you are working on a Java application, then you will require users to install Java, to install your application on a given location. So you will need to have all these instructions on how people should configure the environment for your application to run. And this is exactly where Docker comes in. Docker was created in 2013 by a company called .cloud. The idea was pretty simple but powerful. Take the existing Linux container technology and make it easy to use. Instead of writing a list of steps for others to follow, you describe everything your application needs in a single file called the Dockerfile. With a Dockerfile, you define the base system that your application needs, how to install dependencies, how to set up the environment variables, and specifically how to run the application. So anyone on any machine can now run your application exactly the same way with just one command. All these instructions that used to be delivered in this way, but now we can use Docker to do all of this for us instead of requiring all the users to go through all of this messy configuration process. Let's see how to install Docker. Whenever you install the Docker environment, you are not just installing one simple thing, but a whole environment based on several different tools that Docker is going to use depending on the situation. The backbone and the building block of Docker is based on a Linux virtual machine that Docker is always using whenever you are running on Mac OS or Windows. Docker requires this Linux virtual machine in order to provide the core for the whole platform to work. This is available in Unix-based systems, but not natively available on Mac OS or Windows. That's why in these installations, Docker is going to install a Linux virtual machine that is going to be used as a base for Docker to run. Docker is using functions of this Linux kernel in order to provide you all the features that you are getting from Docker. It is using the namespaces for isolation, it is using the cgroups for resource limitation, and also is using UnionFS for the different layers of the file system. All of that is coming from the Linux virtual machine, specifically using the Linux kernel. On top of that, it is exposing the Docker engine itself, the Docker daemon, that is the one providing all the functionality that you will be using from Docker itself. So here you have the Docker daemon, that is the main process that is listening for the incoming requests and coordinating everything between the different layers of Docker. Here you have runc, that is the one executing the containers using the namespaces and the cgroups available in the Linux kernel. Then you have containerd, that is the runtime required to coordinate and handle all the different containers. And on top of these two, you have the Docker API itself, that is the one exposing the endpoints that you can use in order to interact with these two different processes. Now, once you have the Docker engine in here, you can use this Docker engine by using the Docker CLI. So whenever you go to the terminal and you type Docker, what you're doing is interacting from the CLI with the Docker API. And you can also use Docker Desktop, that is a GUI provided by Docker, allowing you to use the Docker API, but using a user interface that is much more friendly than using the CLI tool. You can see right here in docker.com, If you go to developers and getting started, you can install Docker Desktop. In this case, I'm running macOS for an Intel chip, so I can download this specific Docker Desktop setup. You can pick the one that you are running on your computer, or you can install the different parts of Docker by going here. So you can see Docker Engine, the Docker CLI client, Docker Compose, and all the different parts of the Docker environment. If you are using Docker for local development, I highly recommend you to install the Docker Desktop. So you will have the Docker CLI, you will have a GUI that you can also use for seeing the running containers, all the different images. You can do everything with just the CLI, but if you have the option, I highly recommend you to go through Docker Desktop, giving you the whole Docker environment. You can click on the corresponding installer here for the operating system and architecture you have on your computer. And once you go through the whole installation process, you will see this dashboard that is the main dashboard for Docker Desktop. So as you can see, you have a Docker image for pretty much every technology you might be working with. You can see in here you have Redis, Nginx, and Postgres, but you can find images for Node.js, MongoDB, Java, Elasticsearch. Whatever technology you are working with, you probably have a Docker image for that specific technology. So now that we have Docker installed, let's see how we can use it to deliver and ship our applications. So in Docker, we can use a Dockerfile to specify all the instructions that Docker needs to follow in order to create the environment, configure the environment, install the application, and then execute the application. So we are defining all the different steps that Docker needs to follow in order to prepare the environment, install our application, and ship the application itself. So we are going to put all that definition inside a Dockerfile. We can build that Dockerfile, and in the process of building a specific Docker file, we end up with a Docker image. The Docker image contains everything our application needs in order to be executed. It contains our code, dependencies, environment variables, file structure. You can think of it like a snapshot of a fully configured system, a fully configured computer with the operating system, the environment variables, your application, everything ready to be executed. Once you build the image, that image becomes immutable. It doesn't change, it cannot change. If you want to change your Docker image, you need to change your Docker file and build the Docker file again in order to create a brand new Docker image. That's one really cool thing about images, that once you build them, they are not going to change. Now that we have our Docker image completely built, we can execute that specific image in order to get a Docker container. It is your application already installed and executing in that specific environment. Every time you run a Docker image, Docker will create a brand new Docker container. Each container has its own file system, its own network stack, process tree, and environment. And all of this is interacting with that virtual machine that we saw at the very beginning and executing really close to the actual hardware that you have on your computer. That's why Docker containers are crazy fast, because they are interacting really close to the hardware, in contrast of what you will get if you run a virtual machine. Of course, you can use the same Docker image to launch and execute more than one container, created using the exact same Docker image, and that's one of the really cool benefits that you get out of Docker. You can create as many containers as you want using the same Docker image. Now that we have seen all of this, let's see how we can create our own Docker file in order to deliver our application. If you take a look at the structure that we have in our examples, we are working with Docker, tutorial, and inside tutorial we have multiple artifacts that we can Dockerize. In this case, we'll be working with backend, that is the one that we saw during the example. Here you have the README with all the instructions that we need to follow, and in here we are going to create a new file called Dockerfile. So you can see the moment we create the file with this name, we now have a valid Docker file that we can execute, and you can also see the Docker icon right here. If you remember from our Docker desktop, you can see that you have images for different types of technologies. You have Redis, Nginx, Postgres, and I mentioned that you also have images for different programming languages that you might be working with. So, of course, if you search Golang Docker image, you will get this specific Docker image for Go. you can see that we have the recent tags. You have 124 that at the moment of recording this video is the latest version of Go that we have available. So here we are going to type docker run. So with this, we are telling to Docker that it should start a new container based on a specific image. We are also going to pass two specific flags in here. The first one will be the I for interactive, and we'll use T for TTY. This will give us a terminal interface so we can see the output as if we were running inside of a given shell. After the flags, we pass the name of the image, in this case Golang, and we will use 124. So after we use this image to create a new Docker container, we want to cut and we want to show the content of etc/os release. So what we're doing with this is we create a new container using this image, and once we have the running container, we are going to take the content of this file and display that file on screen. So whenever we execute this, you can see that Docker is saying, I'm unable to find this image locally. I don't know what that image is. And you can see in here in Docker images, we don't have any images right now. So Docker is pulling this image from the registry that we saw before. It is pulling the image from here, doing this docker pull Golang. And once it finished pulling that image, it is using the image to create a new container and execute that container. We have the status downloaded for the new image, and this is the output of this etc/os release. You can see that the official Golang image is based on a Debian. Just by using the Golang image, we know that we are using a Unix-based system and we are also installing Go. So we can use this Docker image to implement these two requirements right here. We can use a Unix-based system and also install Go. Exactly as you have the Golang image, if you search Docker node image, for example, you can see right here that you have the official Docker image for Node.js. So now back in our Docker file, we can use the from keyword and we are going to specify Golang 124. With this from keyword, we are telling to Docker, hey, start building this image using the official Go image that already includes Golang 124 on top of a Linux system. Now remember, every Docker file must begin with a from keyword. This is the foundation for everything else. This is defining what operating system and what base image we are going to use in order to start building our own image for the artifact that we are building at this moment. The next step is to define the folder where we are going to be working inside the Docker container. So for this, we are going to use the keyword called workdir, and we are going to define this specific path called /application. This tells Docker that from now on, every command in this Docker file will be executed inside the /application directory. You can think about it like this. We are creating this directory and then moving to this directory, so every line from now on will be executed in here. Now that we are located in this specific folder, we are going to use the keyword called copy, because now we want to copy content from our local machine, from our folder where we are running this, into this specific folder within the container. So in this case, we are going to copy everything from the local folder in our computer, and we are going to copy in the directory where we are located inside the container. If you know anything about Docker, you will realize that doing this is not recommended at all. In this case, we are copying everything from the current directory into the /application folder in our container, but with this, we are copying everything, every file that is in here. We are going to take care of this in a few minutes. Just stay with me for just a moment. For now, we are just going to copy everything from our current folder into the /application folder in the container. You can see that we will have the Go module, we will have the Go sum as well, we'll have the README, and we will have this CMD folder that is where our main file lives. Since we already have Go installed because we are using the Go image, now we can use the run keyword to execute a specific command within the container. In this case, we are going to run go mod download. Now with this command, what we are doing is using the Go module that we have in here and downloading all the dependencies that our application requires and putting all of those dependencies within the Go path inside our container. If you think about it, if we go to a terminal and we see the content of this specific folder, all of this is exactly what we have inside the /application folder within our container. So we are doing go mod download, and this command is getting the Go module and downloading all the dependencies in the container itself. In here we are doing that in our local computer, but with this line we are telling Docker, hey, take a look at the Go module and download everything you need from there and ensure that all the dependencies are ready for me to use. Now that we have our dependencies installed, we are going to run another command in our container, and we are going to say go build, and we are going to pass a name for our application. So in this case, we'll pass the name application, and then we are going to tell Go which application it needs to build. So we are going to pass cmd/application/main.go. As you can see, since we are located at the root, think about this folder like being inside the /application within the container, and we are telling Go to use the application name for our file and then build the main file located in cmd/application/main.go. And you can see that the moment we do this, now we have this new application binary that we can execute. So we can just say execute the application binary, and now we have our application executed. What we are doing with go build is compiling our Go code and generating a binary that we can execute. That's exactly what we are doing inside the Docker container with this specific command. If we take a look at the instructions that we have in our README, it says that we need to define these environment variables right here. We need environment, HTTP server, and MongoDB URL. So we can copy all of this and we can paste them in here. Since we want to create an environment variable, one keyword that we can use is called environment. And we can use this environment keyword to define all the different environment variables that we need within our image. Now, as you can see, we are defining values for these variables right here, but you can override these values later whenever you are running the container. So here we're basically saying our application requires these 3 different environment variables. I'm putting these default values right here, but I can change the values of these variables later when I'm running the container. And now that we have our Go application built and we already have our environment variables, we need to define the entry point for our Dockerfile. In this case, we will use the keyword entry point. So here we are defining what's the entry point for our Docker image. In this case, since we already have this application right here, and as you can see, we can execute this application like this, that's exactly what we are going to define in the entry point. Application as the entry point. What we are doing with this line is defining what's the executable that we are going to execute whenever our container starts. If we pass arguments whenever we are running the container, this executable won't change because we are defining this as an entry point without taking any consideration about the different arguments that you can pass whenever you run the Docker image that we are going to create. So we are not allowing anyone to change the entry point of our application. Now, one thing that we want to allow is passing arguments to this specific entry point. So you can think about it like doing /application and then passing HTTP port equals whatever and argument 2 equals whatever. So we can execute the application in this way, passing arguments. So all of these arguments are handled by using a specific keyword called cmd that is handling all the different arguments that we want to pass to our entry point. So as you can see, we use the README with all these instructions and we use it to define our own Docker file that now we can build to create a Docker image that anyone can execute. And the really good thing about this is that our application will be executed in the exact same way with the exact same environment variables and the exact same configuration, regardless of the environment where this Docker image is executed. So if a user has a Windows operating system or they have Ubuntu or they have Debian, we don't care. As long as they use Docker to run our application, everything will be running in the exact same way every time they run our application. Now that we have our Docker file, let's take a look at how we can use it to build a Docker image that we can use to create different containers. We are going to execute docker build. So in this case, we are telling Docker that we want to build a specific Docker file and use it to create a Docker image. For doing this, we are going to use the T flag to define the name of the image that we want to build using this Docker file. Now, the T flag is the same as passing the tag flag, because we can pass the name of the image itself, and optionally we can pass a tag for that specific image. So in here we are passing the T flag, and we are going to call this cool backend, and then we are going to pass a dot. I really want you to focus on this specific dot, because what you're defining here is the build context. It is not only where your Docker file is, it is not only where you have all the code, it is the build context that you are passing to Docker. So in this case, what Docker is doing under the hood is taking everything that you have in this specific folder, is going to compress this, is going to send this to Docker. Docker will uncompress all the content and use everything that you have in here as the build context. Since this is a Go application and you have just a few files and folders, it is not that bad. But if you're working, let's say, with a Node application and you're passing a dot here, you will be passing the Node modules, you will be passing every file that is from the operating system, like those DS store files that you have in Mac. You will be passing every secret that you might have, every hidden files that you might have. So it is really important that you take this into account. We are going to cover this later, but I just want you to know that whenever you are passing a dot here, you are passing everything that you have in this folder and passing all of that as the build context that Docker is going to use. Now, if we execute this, in here what Docker is doing is building our Docker image using both the Docker file that we have and also the build context that we have passed whenever we execute the build command in there. So as you can see, it is using the from docker.io library Golang 124. It is setting the work dir to /application, copying everything, running the Go mode download, building the application itself using Go, and finally it generated this image with this specific signature, and we use the name cool backend in here. So now if we execute Docker images, you can see that we have Golang 124, that is the image that we fetch from the registry. But now we have this image called cool backend, and you can see it was created 51 seconds ago and it weighs 1.24 gigabytes. Okay, so take a look at this, because this will be really important later. As you can see, what we did so far is take our Docker file and build it in order to create a Docker image. Now that we have our image, one thing that we can do is execute this image in order to get a Docker container with our application running inside of it. In order to run a specific image, we are going to say docker run. In this case, we are telling Docker to stop and also remove the container whenever our application stops, whenever we've closed our application. And now we can pass the name of the image that we want to execute. In this case, it is cool backend. So now, as you can see, we get our current environment production and starting HTTP server at port 8080. So we do have our container up and running, but one thing that you should be really aware is that every time you create a container, it has its very own file system, its very own network, and it is completely isolated from the host where you are executing that container. If you see here, the container itself is listening at the port 8080, but if we core to localhost 8080/ping, you can see that there's no one listening at the 8080 port, because we're executing this in our host in my local computer, but the 8080 port is available only in the Docker container, not in my host. So how can we communicate with the Docker container using this specific port? For doing that, we can bind a port whenever we are running the Docker container. So here we can add another flag, that is the P flag, that is the port binding. We can tell Docker that we want to bind this specific port from my host, from my local computer, to this specific port in the Docker container. We know that the cool backend that we just executed is listening at the port 8080. We can use that to bind the port, let's say 1234 to 8080. In this case, we are telling Docker, whenever you run this container, bind the port 8080 of the container to this specific port in the host, in my local computer. So Docker will open this port 1234 in my local computer, in this computer where we are running this command, and will bind this port to the 8080 port in the container. You can see in here, whenever we run the application, it is running on the 8080 port. So we can use the port 1234 in our local computer, in our host, to communicate with the Docker container. If you want to use the same port, you can just change in here and just bind the 8080 port in the host in my local computer to the 8080 port in the container itself. In this case, you can see that if we use 123 again, it will fail. But if we use 8080, now we have a response and we can keep interacting with this API. And here you have the request, the response, everything inside the container itself. You can see that this response that we are getting here is the exact same response that we get if we execute our application locally, but now the application is being executed in the Docker container instead of being executed in our host. How can we see this? In Docker, we have an option called Dockerfiles. So here you can see all the containers that we have created and their status in the Docker environment. You can see the container ID is this one. The command that we executed was /application with no arguments. It has been up for 45 seconds. And here you can see the ports, the port binding that we did before. And this is a name assigned by Docker to this specific container. One thing for you to know is that doing Dockerfiles gives you the exact same output that you will get if you go to Docker Desktop. You can see all the containers that you have. In this case, you have this one with this name and this ID ending in 38, and the status is running. Here you can see the ports, and from here you can take different actions on this specific container. So the moment we go to our container here and we close it, now you can see in Dockerfiles that we don't have any containers, and in Docker Desktop, now you don't have anything in the running containers. Now that we have our backend fully Dockerized, we are going to work in our frontend, and we are going to introduce this concept of multi-stage builds. Looking at the project structure, we can also see a README giving us instructions on the steps that we need to follow in order to run our frontend in development. We need to install Node.js version 18 in this case, then copy the content of our GitHub repo into the folder we are working with. We need this environment variable. After having the environment variable, we need to run npm install to install all the different dependencies for our frontend. And finally, executing npm run dev. As you can see, the frontend is listening at the 8081 port. So we're going to do for our frontend the exact same thing that we did with our backend. We are going to create a Docker file, and we are going to open the Docker file from our backend just to have that as a reference over here. In this case, we were using from Golang 124, so our backend image is based on the Go image version 124. For our frontend, we will do the same, but we will base this on Node, and we'll use version 18. This base image right here is using this Docker image where you can see Docker pull node. So this is the name for the image itself. Here you have all the different tags that you can use for this specific image. We are going to use version 18 because that's what our README is requiring us to use. Looking at the instructions, we need only one environment variable, being this one. This environment variable is defining the ping URL for our backend so the frontend can communicate with the backend itself. After having this, we are going to define our work dir. As before, we are going to use /application. Exactly as we did with backend, we are going to copy everything. So we are going to put that in here. And remember that whenever we are copying like this, copy everything from our local folder, that is this one, to the /application folder within the Docker image when we are going to build this. We need to run npm install like this. So we are going to run npm install. And finally, for running our application, we need to run npm run dev. Now, since in this case, we don't have a binary or we don't have an executable that we can just execute using entry point, we are just going to use cmd, and here we are going to pass npm run and finally dev. So this will be the structure of our Dockerfile. Going to a terminal, if we execute docker images, we can see we have our cool backend, that is the image we created for the backend itself. And now, since we are located in the frontend, we are going to run docker build. Again, we are going to pass the T flag for specifying the name of this image. In this case will be cool frontend. Now remember, when we pass the dot in here, we are saying that we want to pass all of this content as the build context for Docker. So what Docker is doing here is taking the entire content of this folder, compressing that, sending that to the engine, and compressing all of this and using this whole structure with all these files and folders as the build context. If we do this, we can see that we are building based on this node 18, setting the work dir as /application, copying everything, running npm install, exporting the image and exporting the layers. We are going to review this later. And here you have the output for the image named cool frontend, and this is the image signature. So if we execute docker images, you can see that now we have cool backend and also we have cool frontend. And take a look at the size, 1.49 gigabytes. Now we can execute docker run and we can pass the name of the image we want to run. So we get a running Docker container based on this image. Doing this, you can see that server ready in 294 milliseconds, and here we have our localhost 8081. And if we open a browser, we can see that nothing's happening. And the reason is because, remember, this 8081 is only available in the Docker container, not in our host. So again, we want to bind this 8081 port from our container into our host so we can access the application running in the Docker container. Looking at the output of Docker desktop, you can see our container right here with status running. And again, you can use Docker PS to see the status of the container. In this case, you can see the same output being this container executed right here. In Docker desktop, you can see that for this specific container, you can stop the container by clicking on this button right here. That's exactly as doing docker stop and passing the container ID. Here you can see the container exited in Docker desktop, but if you execute docker ps, you don't see anything in here. And the reason is because Docker PS is only showing you the running containers that you have at the moment. If you want to see all the containers, you can execute Docker PS using the all flag. And here you can see the exited status for this container. From a stop container, you can say Docker start, and you can pass the same container ID again. And you started that container again, showing you running status here. For whenever you finish working on that container, you can just stop it without deleting the container. In our case, we want to stop the container but also delete the container. For doing this, we can execute docker stop and pass the container ID and confirm the container was stopped. And now we can execute docker rm. In this case, we want to remove this specific container. So now executing docker ps with the all flag, you can see we have no containers at all. Since we want to access the container port and we want to bind the container port, we are going to execute docker run, but we are going to pass the p flag in order to bind the port from our host to the specific port in our container. So we want to bind port 8081 in our host to the 8081 port in our container. Executing this gives us the exact same output as before. As we can see in here, this is the front end of our company. We can see some menus, some options in here. Looking at this section right here, the front end is trying to communicate with the backend every 2 seconds and fetching the status from the backend. In this case, since we only have the front end running at the moment, and the backend is down, we can see that exact message right here. We have our frontend up and running. Let's take a look at our Docker images. This is the image that we use, cool frontend, and take a look at the size. It is 1.49 gigabytes. And this is the perfect situation for me to show you a concept called multi-stage builds. In Docker, multi-stage build is a technique that lets you use multiple from statements in a single Docker file. This allows you to separate the build environment from the runtime environment. And this is really important because build environments are usually really big. They include things like node, compilers, source files, and that's the reason why you see these sizes right here. We can use multi-stage builds to separate one stage being building the application from a different stage that is serving the application itself. You can use the as keyword to assign a name for this specific stage. In this case, we are going to call this builder. So the name that you put after the as keyword is the name for this whole stage until you have a new from keyword. If we take a look at the instructions that we have in our frontend, we can see that we're using npm install for getting the dependencies, and then running npm run dev for running our application in development mode. If we want to build our application, we have an option called npm run build. In this case, Bit is compiling and building our application for production, and it is generating this output right here. You can see this new dist folder that in here it didn't exist. But now if we take a look at the content of our folder, we have this dist folder. Looking at that, here is our application completely compiled for production. Take a look at the difference between the amount of files and the size of these files and folders compared with our application compiled and built for production. So we could do one stage doing this build, generating this distribution folder, and then a different stage using the content of this distribution folder to execute our application. And that's exactly what we want to do in our frontend. We are going to use this stage for building our application, and we are going to use a different stage for running the output of the builder. This is our build stage, and now we are going to create a serving stage. If you remember, multi-stage builds allow you to use multiple from statements on a single Docker file. So now if we use a different from keyword, you can see that we have this line in here showing us that this is one stage, and from here it is a complete different stage. In our case, we use Node 18 as the base image for building our application, and now in this stage we can use a smaller image as a base for serving our applications, since now we don't need the whole Node 18 base image as we required before. In this case, we could use something like Nginx Alpine. This is a really small image that we can use for serving our applications, and same as before, we are going to assign a name for this stage. In this case will be serve. So we have one stage for building our application and a different stage for serving our application. As you can see from here, this is a brand new image, so the output that we generated before is not present, is not defined in this new stage. So one thing that we want to do here is copy, and we want to copy from, so we can pass a from config here and define from which stage we want to copy content. So in this case, we want to copy from builder. What do we want to copy from the builder stage? We want to copy this distribution folder that contains our application completely built. This folder was created in the /application because this was our work dir before we execute npm run build. So in this case, we want to copy from /application/dist, and we want to copy this into our Nginx serving directory. In this case will be user share /nginx/html. What we are doing with this line is specifying to copy that we want to copy from a previous stage. So we need the name of the stage here. That's why we define the name for each of the stages, so we can reference these stages where we need them. In here, after defining that we want to copy from builder, we want to copy from this folder. This /application was the workdir that we created, and after running npm run build, npm will create this folder right here, and we want to copy the entire content of this folder into the Nginx default folder, that is this one that we have in here. Now that we have the content of our application inside the Nginx default serving directory, we can just execute Nginx. For doing that, we are going to use cmd, and we are going to just execute Nginx. Now, by default, every time you execute Nginx, it goes to the background and runs as a background process. We need to ensure that this process that we are running right now, in this case Nginx, is always staying in the foreground, because otherwise the container will shut down, understanding that whatever we executed here already finished. But we also need to pass a global flag in here, and we need to define that we don't want to run this as a daemon, we want to run this as a foreground process, and for doing that we use daemon off. So just by doing this, we are executing Nginx and telling specifically, hey, don't go to the background, just stay here in the foreground as long as this Docker container is running. Now that we have our Dockerfile, we can go back to our terminal, and we are located right here in the frontend directory, so we can execute again docker build. We are going to pass the tag name, in this case cool frontend, and the build context. In this case, remember, we are passing everything we have in here. And after 24 seconds, looking at the output, we are using metadata for Nginx Alpine and also metadata for Node 18. Here we are defining our workdir, running npm install, then running npm build. Once we execute this stage, we have this output in the builder stage. So now we are copying from the builder stage into the Nginx default directory here, and we have the cool frontend image generated with this signature. Now, if we take a look at Docker images, we can see our cool frontend and look at the size of the image that we generated. We moved from 1.49 gigabytes to 48 megabytes. So that's a massive difference in the size of the image that we are creating. This is the advantage of multi-stage builds. We can use one stage for building our application and a complete different stage just copying the output of the builder stage. So we copy to the final image only what we require from the building stage and not the whole thing. You can see in here our frontend weighs 48 megabytes compared to a Go application weighing 1.24 gigabytes. So we can do the exact same thing for our backend using multi-stage builds, so we can reduce the size of the images and being much more efficient in the resources we are using to deliver our code. Now that we have our frontend image completely built, we can use Docker run to run our image and get a running container based on that image. And we want to bind the port from our local computer, our host, to the running container. Now, remember, we introduce Nginx in this serving layer, so our application is not listening at the 8081 port anymore because Nginx is running at the 80 port, at the HTTP port. So in this case, we want to bind the 8081 port from our host in this computer to the 80 port in the container. This is the port where Nginx is looking at. And from here, we want to use the cool frontend. Now we have our application up and running, and you can see that in here we have our frontend using this container right here. And looking at the different images, we have cool frontend weighing only 48 megabytes. So that's a massive difference, a massive improvement in size compared to the 1.24 gigabytes we have in backend. we can use the exact same thing for our backend in order to reduce the size of our image. As you can see right here, it weighs 1.24 gigabytes at the moment. So we're going to follow the exact same steps in order to move from our single stage build to a multi-stage build for the backend itself. Same as before, the first thing we are going to do is assign a name for this stage. In this case will be builder. For that, we use the as keyword in here. All the configuration about the environment is something we're going to move from the builder stage to the serve stage, because environment configurations are used when the application is executed, not when the application is compiled. So we are going to move this in a minute. We are going to define this work dir as /application, same as before. We are going to copy everything, running go mode download, same as before. And for now, let's keep the build as it is. Once we execute go build, what we are doing is compiling our Go code available here based on the entry point, based on the main file from our Go application, and using this code to generate a binary that has our application ready to be executed. We are going to create a different stage here, but now we are going to base this stage on a complete different image that is smaller than the official Golang 124. For that, we are going to use Alpine. That is a really small image that you can use. Remember, this is a brand new stage and we don't have anything. Think about it like if we just install this operating system right here. So the first thing we are going to do here is move the environment definition to this section, because now when we are executing the application, we do want the environment variables in there. Then we are going to copy content from the previous stage. So we need the from here, and we want to copy from builder. And what do we want to copy from the builder stage? We want this binary created using go build. And where is this binary located? Right here in /application, because after you set the work dir, every command that you execute after setting the work dir will be executed in this folder. So from our builder, we want to copy from /application, and we want this application binary, that is this one, and we want to copy that in the current directory. Now, since we already have this application binary right here, the way we execute the application is the exact same thing. We just take this binary and we execute it like this. So we don't need any changes in this stage right here. But where we do need a change is in how we create this application binary. Looking at how we are building the application binary, we are passing just the name being application, and we are using the main file located at cmd/application/main.go. We need to make a few changes in the way we are building, because now we need to build this application in order to be executed in this Alpine image that we are going to use in the serving layer. So for doing that, we are going to run and we are going to pass a few configurations to the Go build itself. The first one is Go OS, and we want to set this to Linux. The reason we are doing this is because we are building this application binary in order to be executed in this Alpine distribution, in this Alpine stage, based on the Alpine image, and this is a Linux image. So we want to ensure that the application we are building, the binary that we are compiling and building, is targeting the Go OS Linux. In this case, we are building the application binary to be executed on a Linux environment. Exactly as we have the operating system, we are also going to define the Go arc, and this is for AMD 64. In this case, we are building the binary to be executed on a Linux operating system using AMD 64 as the architecture. As you can see, you can use these environment variables to define which operating system and architecture you want to target when you want to create images for different operating systems. If you want to deploy your application on a Raspberry Pi, you need to target for ARM in here instead of AMD 64. In this case, since we will be deploying this on a Linux environment with AMD 64, we are going to define both operating system and architecture for this targeting Alpine system. Finally, we need to define a different configuration for the Go build called cgo_enabled, and we are going to put this in 0. The reason why we want to configure the Go build environment to not use C dependencies in this case is because if you notice, we are using the Golang 124 based image, which is based on a Debian operating system. In Debian, we do have some C dependencies that we can use, which are not available in the Alpine image. So for whatever binary that we are building here on this stage, on the builder stage, we need to ensure that the binary created in this stage is perfectly fitable in the image that we are going to use in the serving layer. That's why we want to ensure that the configuration that we use for building this application binary is the exact same configuration that will be available in this stage when we want to run this exact same binary. That's why we are disabling the integration with external C libraries, because in Debian we do have that integration, while in Alpine we don't have it. So we want to ensure that whatever we generate in here can be executed without any problems in the next stage, and for doing that we need to ensure that we are building with the exact same configurations that we will have whenever we execute the application. Now that we have our Dockerfile, we can Docker build. So we are going to pass the tag. This will be cool backend, and we are going to pass the build context for Docker. So here, if we say Docker images, you can now see that the cool backend is waiting only 19.8 megabytes compared with the 1.24 gigabytes that we had before. Now, again, we can just Docker run because we want to run an image and we want to bind, in this case, the 8080 port to the 8080 port in our container, and we want to run the image called cool backend. In this case, you can see we are running in production, starting server at 8080 port, and here we can curl from localhost 8080/ping, and there we have it. We have the PONG response in here, we have the application receiving traffic, and just looking at the Docker images, we have just 19.8 megabytes instead of 1.24 gigabytes. At this point, we need to start taking care of the different files that we are sending to the Docker builder. So for that, we need to know how to tell Docker to ignore files that we don't want to process in the image building process. In the exact same way that we have our git ignore file, where we can specify the files and folders we don't want Git to track within our application, in Docker, we also have a file that we can use to tell the Docker builder to ignore certain files from the build context that we are passing every time we are building a Docker image. Remember that when we are building a Docker image, we are passing the tag, specifying the tag for the image that we want to build, and then we are passing a dot here. As you remember, this dot here represents the build context that we are passing to Docker in order to start building the Docker image. Now, since we are located in the frontend folder, when we pass a dot here, we are passing every file and folder within this folder where we are located right now. As you can see from here, there are some files and folders we don't want to send to the Docker builder because they are going to be generated by the builder itself, or just because we don't want them to be part of the builder. For example, this node modules folder will be created every time we say npm install. So we want to ignore this folder from the Docker builder. In Docker, there's a specific file that we can create called Docker ignore. You can put Docker ignores in every context that you are about to send to the Docker builder. In this case, we want one for the frontend, and we also want one for the backend. In the case of the frontend, in the Docker ignore, we want to ignore, for example, the node modules. We don't want this folder to be sent to the Docker builder because we know it will be generated every time we say npm install. We can do the same for the dist folder, because this folder will be created when we run npm run build. We can do the same for the readme, since it won't be used at all in the Docker build context. So as you can see, you can define all the different files and folders you don't want Docker to process whenever you are building a Docker image. And having this file is really, really important because what you are doing is reducing the size and the volume of the building context that you are sending whenever you are building a Docker image. You could also have some files and folders in here defining secrets or defining configuration for your application, and you don't want those files to be part of the Docker context. In that way, you are reducing the size, but also making sure that you are not putting any sensitive information as part of the building context you are sending to Docker. You can see right here in documentation all the different configurations and all the different attributes that you can put in this Docker ignore file, where you can put it, the different hierarchy that you can use for the Docker ignores, the syntax on how you want to exclude different files and folder, putting comments, and all the different rules that you have when working with a Docker ignore. So yes, without a Docker ignore, your image will be built in the exact same way, but it will take much longer. It could make your process much more insecure if you are not ignoring files and folders that should not be part of the building context. But most important, if you have a Docker ignore file, you can ensure that your building process is building exactly what you need to build out of the Docker images, ignoring everything that should be ignored during the image building process. So in this course, we have covered what is Docker, how to install Docker, what's the difference between a Docker file, an image, and a container, how to create your Docker files, how to build them to create Docker images, how to launch containers from images, how to stop and how to start the different containers, how to use multi-stage builds to improve your Docker images, and how to use the Docker ignore to make sure that you are building exactly what you need to build. There's a lot more around Docker that we need to understand. Docker networks using Docker Compose, using your own scripts to deliver your application using Docker, using Docker registries, authenticating to different registries. There's a lot more going on around Docker. You tell me what's missing, what you would like me to cover next. Thank you very much for your attention. Thank you very much for your time. I hope you took something new from this video. If you have any questions or any comments, please let me know in the comment section so I can get back to you as soon as possible.